finding our residuals, we're going to take our linear regression line or line of best fit. So you can do the line of best fit by hand, or you can find the linear regression line from your calculator. Doesn't matter which one you use, depends on how accurate you want your residuals to be. Some teachers are going to require you to do it from your line of best fit, and some will require you to do it from your linear regression line from the calculator. So the one from the calculator is y equals 32.54x minus 205.84. And this is the linear regression line for this set of data. So what we do from here is we're going to take our temperature, these are our x values, and we're going to put them where x is in the equation. And that will give us our predicted ice cream sales. So they've given us the actual ice cream sales. Now we're going to get the predicted from our line of best fit or our regression line. So when we do that, we have 32.54 times 14.2 minus 205.84. When you do that, you get 256.23. When we do that with our 16.4, we get 327.82. We're just going to do that all the way down. So now we have all of our predicted ice cream sales. And when you compare them with your initial ice cream sales, you should have some that the predicted value is lower and it's higher. And what this is our predicted ice cream sales are now coming from our line of best fit. And when we think back to the line of best fit, we had some of our original points above and some below. So that's how it should be with our predicted ice cream sale. We should have some above the actual and some below the actual, because we want this set of data for our predicted to go along with what should come from our line of best fit graph. So then what we do is we take our ice cream sales and we subtract our predicted ice cream sales from them. So we're going to do 215 minus 256.23, and we're going to get negative 41.23. And you're going to have some negative residuals and some positive. For the next one, we have 325 minus 327.82, and we get negative 2.82. We have 185 minus 181.39, and we get 361. We're going to do that all the way down. So this is what we get when we get our residuals. And like I said before, we had some of our predicted ice cream sales were above or below the initial ones. So if our line of best fit, and since this is with the calculator, it's going to be pretty accurate, but if our line of best fit is pretty accurate, you're going to have about the same amount of negative residuals as you do positive. And here we have 4 negative and 5 positive, so our line of best fit is really good for this set of data. So then what we do is we take our temperature, which is our x value, this is our x, and then we take our residuals, which is our y value, and we're now going to plot them on a graph. So to get our points on the chart down here, I want to go by about 5s for my y values, and then we'll go by 2s for our temperature to fit it all on this graph. So for our first one, our temperature is 14.2. So we're going to go over 2, 4, 6, 8, 10, 12, 14, and we're going to go down a negative 41.2. So it's just going to be a little bit off the line for both pieces. We do the same thing for 16.4 and negative 2.8. So 2, 4, 6, 8, 10, 12, 14, 16. And that's about where our point goes. So we're going to do that for all of our x and y values. So looking at our graph, we can see that for the most part, without a couple of outliers, our data is all very close to our x equals 0 line. So this would be a good fitting set of data. So the correlation would be a strong correlation for this set of data.